Hey folks, welcome to another edition of Frankenstein Tech Series. Today, we're going to be talking about seats. The biggest question we get from customers whenever we talk to them about their seat selection in a set of cylinder heads, they may not ask it, but it feels like they want to. What does a seat do, Gavin?
Absolutely. So there's a few different things that a valve seat's purpose is. The main purpose of the valve seat is the seal. When that valve goes to close, it needs to be able to close and seal the air inside the combustion chamber. Now this one already has a pre-cut valve or a pre-cut 45-degree seat here, and that's essentially just for when we go to cut the valve job. We'll just pretend that's going to be our 45-degree seat. The valve comes down and it seals right there, and that keeps everything sealed up inside that combustion chamber. While it's sealed down there, it does its second part of its purpose, which is cooling the valve. Now the valve, when it goes to close or open or whatever, it's only cooling it has is the oil that's on the valve stem. So when it contacts this valve seat for that quick little instant, the coolant underneath the valve seat cools the valve seat and then therefore transfers that heat to the valve. So it cools the valve as well. So certain materials, depending on what you're using, might cool better or worse than some other materials. Lastly, and probably its most important purpose of the valve seat, is the valve job that is cut onto the valve seat specific for that port that we're designing. And I would say easily that the valve job is a crucial tool for airflow design. You can make or break a cylinder head port with a valve job, which we'll get further in depth than that later down the road.
Today we're going to be talking about seats. In all reality, the meat and potatoes of this conversation today is going to be on materials. Yes, there are different sizes. Yes, there are even in some very unique cases, different shapes. But today and today only, the majority of it is going to be applied to comparing it to any kind of OEM type of head, and then also full out race heads, and it's going to be how we select the proper material for the proper job. Now, of course, there's a whole big relationship between valves, guides, and seats. And well, like I said before, mashed potatoes is right in the middle of all of that. So to start it all off, why don't we talk about the most common type of seat material that we use here at Frankenstein. You don't necessarily find it in OEM, LS, or LT heads, late model heads, or Fords for that matter either. Basically what you end up with is you end up with a powdered metal seat. Or if you've got a LS9, a LT4, or an LS7, you're gonna also come out with a Killer B seat from Durabond, since they come with a titanium intake valve in them. Now, instead of all that, those are powder metal and Killer Bs. What do we mainly use? Ductile iron. Why don't you go ahead and show us over that, Gavin?
Well, ductile iron is the most commonly used valve seat when it comes to aftermarket heads. These can be used on titanium as long as the titanium valve is coated. Inconel valves, stainless steel, even stock valves can be used on the seat. It's a lot better than powder metal at taking the heat out of the valve seat. It's a lot harder, so they're going to last longer. And then even when you go to cut the valve job, these will actually peel off, rather than powdered metal. It literally just turns into a dust when you cut it. Another option that we have here is from Tucker, and this is a tungsten alloy seat. It's an extremely hard valve seat. In fact, the longer it runs, the harder it gets.
You're telling me with more heat cycles, that thing actually gets harder and ends up essentially doing a better job being a valve seat.
That's what they say. I've never personally used it, but
it's amazing. Science is absolutely amazing. So if these are going to be your most popular iron choices or steel choices, if you've also heard that as well. The Tucker stuff is rather rare, but it is very excellent quality stuff. It's not maybe necessary in everything, but maybe a marine application with Inconel valves in it, something along those lines, it would be great for it. If you absolutely want diesel, probably another wonderful application as well. Moving on from the iron stuff, we're now going to get to a synthetic or maybe more exotic material here that if you're used to running spread port big block heads or Hemi stuff or really exotic small block stuff, then this is probably more your speed or what you're used to dealing with. And that is a couple of different options from a couple of different companies. Here, over here, we've got CHE B1, CHE BX, Moldstar 90, and then beryllium copper right here. There's a few different materials and a few different things as to when and where you might use them. But why don't you go ahead and explain to me with the CHE stuff over there with the B1 and the BX?
Now the CHE valve seats for B1 and BX, generally the B1 is going to be used on your intake side for a titanium intake valve. These do pretty well at cooling and having a higher rate of elasticity. So when the valve hits it, it's not just bashing it, it actually absorbs that hit a little bit. As far as the BX, this is going to be used on your exhaust side. And the reason why is because this proprietary material that they use on the BX absorbs the heat a lot better. Still a little elastic and whatnot, just not as much. And this one is very similar to this copper beryllium, but there's no beryllium in this, so it doesn't have as many health concerns as what copper beryllium could be.
Right, absolutely. And then when you get to the upper echelons as far as what you're wanting to accomplish in a cylinder head, such as in our P48 Hemi stuff, or any other super high-end top-of-the-line cylinder head, it should come with what's called Moldstar 90. Now, Moldstar 90 has a lot of the same benefits that are in those CHE materials right there, but the only difference is that Moldstar 90 expands and contracts at the same rate, or very near the same rate, as 6061 T6 aluminum. And why is that important? That's important because these billet heads, even if you got water in them, they're having such a wide delta in water temperature range, which means they're having a wide delta in cylinder head temperature range. So you want this seat to, if it's going to have to expand, 1.5, 2 thousandths, to also expand at the same rate as a cylinder head. If it expands too fast, well, then you might be dealing with other issues as far as choking the seat up into the throat or into the port. If the head expands too fast and the seat doesn't expand with it, seat falls down, motor's ruined. That's basically it. And when we are pushing, I don't know, maybe somewhere between 2,500, 3,500, 4,000 horsepower, all the way up to 7,800 in top fuel stuff, we need the best. There's no other question about it. That is the ultimate creme de la creme. Now, it comes with a creme de la creme price as well.
Absolutely.
So do not be mistaken that you can just go down to the Dollar General and pick you up some. The last one that we're probably going to go over as far as materials right now is what's called beryllium copper, copper beryllium. And we did mention the health concerns before. There are some interesting things that when you machine this material, some things can happen. Not really going to elaborate on it much more. Just protect yourselves out there. Yeah. And besides all that, we should go over maybe like a when, where, and why we would choose to use these different seat materials. So let's go ahead and let's circle back around right now to the iron stuff. What do you think about that? As far as, maybe you just got to replace a damaged seat in an OEM head,
right?
Or if you're looking to upgrade something, maybe.
When it comes to factory heads, it's really common to replace the valve seats with a ductile iron. Even when we talk about old school Chevy heads, where the iron as an integral seat is what we call it, where the valve seat is part of the cast iron head. With the new unleaded fuels, we don't like to run that as a valve seat, so we'll actually cut a pocket and put a ductile iron valve seat in it specifically for those fuels. Talking more modern era with aluminum heads, it's just powdered metal will, especially when we start putting some horsepower down to it, maybe some higher spring pressures and RPM, it'll start to degrade and start to kind of flake off. You'll start pulling that valve through the seat. So a lot of times we'll upgrade it to a more harder material that can absorb the impact that the valve is coming back with, but still being able to last long, being a nice economical option. Now, because it is harder when it comes to running a titanium valve, the valves won't last as long on a ductile iron valve seat than would on a copper alloy valve seat.
That's right. And of course, we use these Tucker seats here on the exhaust for all of our top fuel stuff because it is the hardest stuff out there and it's what's proven to work so far. And honestly, I've yet to see anything more impressive just from a chemistry standpoint than that piece right there, outside of the affordability of upgrading any of our cylinder heads here into the CHE B1 or BX properties. These things right here, I've seen guys put 400, 500 runs on them in a year with 275, 280 pounds seat pressure, maybe even a little bit higher, running tie valves. last the whole season, pop them back off, they look cherry. That's pretty impressive to me. Maybe some other folks have higher expectations of what they should expect, but that's me. And then of course over here, once again, these things here, they're getting beat on all the time. It's always hard to judge the longevity of a Mold Star 90 seat, because most time when you see a Hemi head back, it needs to be welded on. And you just don't know how bad that thing was getting beat on before in its prior life. And then once again, this is the material that everybody's chasing when it comes to a synthetic copper, and that's because they're trying to replicate everything that can be found in a beryllium copper, beryllium, whichever orientation of those words you like. That everybody's chasing this material. It is actually a really wonderful performing material, and it's outstanding. The only problem is, a lot like all the other things that we enjoy in life, it has a tendency to try to kill us. So I think that's just about it. I would want to say that there is another video coming that's going to be talking, we already talked about valves, and now we're talking about seats. I wonder what we're going to talk about next. Probably something that has something to do with seat and with some kind of word with concentricity.
Something to do with guiding the valve onto the seat.
We need a guiding light in our lives. Either way, hopefully we get some guidance here next time on this show here, the Frankenstein Tech Show series, whatever we want to call it. And if you guys like it, we're glad you like it. Tell a friend, write a comment down below what part you liked and what part you hated. If you want to check us out for as far as any of our socials, you can find all that stuff up here. If you want to get in touch at my email address, it's right on top of Gavin's face. And Gavin, where's your email address at?
My email is gavin@frankensteined.net, right here.
Thanks for watching. Make sure to like, subscribe, and ring the bell so that we get notifications anytime we upload a video. Thanks, guys.